So for this one, antiderivative. So this is just being multiplied. So that's just going to be multiplied. And then the antiderivative of this is going to be 5 to the x times 1 over the natural log of that base. And so it ends up just being on the numerator to 5 to the x over the natural log of 5 plus c. That's your answer. Because if I take the derivative, it should work itself back to my antiderivative. It should work myself back up to here, right? My antiderivative should derive to what my original function was. So what would the derivative of this be? Well, it would be that 2 times that 5 to the x times the natural log of 5, right? This is just a constant. So the constant you can think of is just right here. And then you can see that these two guys would cancel and you end up with him. Right? Does that make sense? That's why it's the reciprocal, because it's just like why you add an exponent and divide, because if you were to take the derivative, you would multiply by the exponent and subtract. So it's just the inverse of that. For something like this, you want to look at your most difficult piece and do u substitution. So like for this, I would do the exponent, that's sine negative 3x, as my u. And so I would say, well, if my u is sine of negative 3x, then my du, or my derivative of that, is going to be cosine of negative 3x times the derivative of the 3x, so times that negative 3. So that will take care of this, right? The sine of 3x. It'll take care of this cosine. The problem here is the 9. I have a negative 3. I need a positive 9. So I need to multiply both sides by negative 3. And that will give me my 9 cosine, which is what I'm looking for. So that'll take care of this piece. Then I'm going to rewrite everything with my u's. My negative 3 du, that takes care of 9 cosine of negative 3x. Okay? And then my e to the u takes care of my e to the sine of negative 3x. Right? Then I'm just going to do my antiderivative. The antiderivative of e to the u is just e to the u. So my antiderivative of this is going to be negative 3 e to the u plus c. And then, of course, I need to go in and fill back in my u with what my u was. And so negative 3 e to the sine of negative 3x plus c. And that is my answer. Okay, so tangent to the negative 1 is the same thing as the arctangent. Okay, so for arctangent, it's going to be your u squared plus 1 in the denominator. In this case, the u is what is inside the arctangent. So you can think of this as the arctangent of u. Okay, so the arctangent of u is going to be my u prime, right, over u squared plus 1. That's my derivative of arctangent. Okay, so dy dx of arctangent is going to equal the derivative of the function over the function squared plus 1. So in this case, the u piece is 4x squared. So u prime, or the derivative of that, is 8x over this function squared plus 1. And so simplifying that would be 8x over, I have to square the 4x squared, so that's 16x to the 4th plus 1.
And that's your final answer.
And that's my final answer.
Okay.
So when you see something like this, you have a dy dx, which if they want a general solution, then they want you to take the antiderivative of it, is what they want you to do. Because they've clearly given you the derivative right here, right? And you'll notice you have an x and a y. This is where you need to get the y's with the dy's and the x's with the dx's. Okay? So the first thing I'm going to do is I'm going to manipulate this particular one so that my y is over there with my dy and my dx is over there with my x. So I'm just going to multiply the y squared over and move the dx over as well. So I end up with y squared dy equals 3e to the x dx. So I'm really just moving my denominators over to the other side is what I'm doing here. And then I'm going to integrate both sides, just using my standard integration rules. So my rule for my y is add 1 to the exponent and divide by my new one, right? So that would be y cubed over 3, right? Over here, the antiderivative of e to the x is just e to the x. So I end up with 3e to the x plus c. Okay? I need to get, when I'm finding a general solution, I need y by itself. That's really what they want you to do here. So the first step to getting y by myself is to multiply by 3. So I need to multiply this by 3. That'll give me y cubed over here. 3 times 3e to the x is 9e to the x. 3 times a constant is just another constant. And then I'm going to get rid of that 3 like I would in any equation. I would take the cubed root. Now I will say that c does need to stay within the cubed root because remember we talked about yesterday, the root of a group is not the same thing of the root of the individual pieces of the group, right? So your answer is actually going to be y equals the cubed root of 9e to the x plus c, everything under that root. For this one, you need to separate them. Here's the problem. You have x and y in your exponent. So we have to think back to exponential rules here. So what rule of exponents tells me that I'm going to subtract the exponents? Division. So this is just like saying, well, 3 e to the x over e to the y. Would that not be e to the x minus y? Right. And so now all of a sudden I can separate these, just like I did above. Okay, I can move this denominator over here, and I can move this denominator over here. So I have e to the y dy equals 3e to the x dx. So I end up with e to the y equals 3e to the x plus c. Okay, I actually have not gotten my my initial condition here. I mean, I haven't gotten my final because I don't have my y by itself. How do I get that y by itself? Yeah, I need to do the natural log of both sides. So I end up on this left side, now I have that y by itself. On the right side, I have the natural log of 3e to the x plus c. And this is telling me that if I plug in a 1, I should get ln of 3e plus 1. All right, and so this initial condition says if I plug in a 1, it should equal this. So if I plug in a 1 here, that means the natural log of 3e to the 1 plus c equals the natural log of 3e plus 1, right? So that means my c has to equal 1. Even if I were to solve these for c, right? And all I did, by the way, I plugged in this 1 for my x, and this is what my y equaled. That's all it told me. So if I have this, I can say the e of both sides. And you can see those will cancel. So I have 3e plus 1 equals 3e plus c. Obviously, c is 1. Okay? So all I did was plug in my x that they gave me and set my y equal to that. That's what it means. Plug in your x and they gave you your y.
So C equals 1 would be.
So c equals 1 is my, because see, my general solution left a c in it. my particular solution solves for C and then rewrites my general. So my general solution was this guy right here. I need to rewrite him plugging in my C, and that will be my particular solution. So I have y equals the natural log of 3e to the x plus 1. And that is my particular solution. Okay, so we're going to leave the initial condition stuff right here alone. We're going to leave this piece alone till we do the differentiation. Once again, we want to move my y over with my dy, and we want to move my dx over to the other side. So on the left-hand side, I would have 1 over y squared dy, and on the right-hand side, I would have 2x dx, okay? So now I want to do my integration of both sides. My antiderivative of y squared, well, that's y to the negative 2. So I'm going to add 1. So my new exponent's going to be y to the negative 1. And then divide by that negative, right? So it's going to be negative 1 over y. That's what I'm going to get when I take that antiderivative. Because I add 1 to this and divide by that negative 1. So negative 1 y to the negative 1, or negative 1 over y. On the right-hand side, I'm going to do my antiderivative here. So I have 2x to the first power, add 1. So it's now x squared and divide by 2. So this antiderivative is x squared plus c. So if I need to solve for y, I need first of all y on top. I can reciprocate both sides to do that. So I can reciprocate this and I can reciprocate this. So over here I would have negative y, and over here I have 1 over x squared plus c. And then I need to get rid of that negative. So I would just multiply both sides by negative 1. I get y equals negative 1 over x squared plus c. Okay? That is my general solution. My particular solution solves for c. Okay? So up here, this up here is telling me plug in negative 3 for your x, and your y should equal negative 1/10. So that's what I'm going to do. This value is my x value. This is my y value. So I'm going to plug that in. And I'm going to rewrite my general solution. Y. Well, y is negative 1 over 10 equals negative 1 over x squared. Well, that's negative 3 squared plus c. All right, so negative 1 over 10 equals negative 1 over 9 plus c. Well, I mean, you can do all the algebra you want, but what is c going to be? I need my denominators to both be 10. Yeah, c is going to equal 1. So now I have my c. I'm going to rewrite my general plugging in my c. So my final answer is going to be y equals negative 1 over x squared plus what I found my c to be. And that is my particular solution. So this is going to be a sine, an arc sine. So if I were to rewrite this, this is going to be basically 1 squared minus 4x to the 5th squared. Right? So the square root of 16 is 4. The square root of x to the 10th is x to the 5th. You just divide that guy in half. So this is my a, and this is my u.
So you took the square root.
The arc sine, like the antiderivative of 1 over a squared minus u squared is going to be arc sine. That's going to be that guy. And it's like arc sine of u over a plus c. But in this case, a is going to be 1, so it's not going to make a difference. So I'm really just doing then making sure that this guy is accounted for up here. And he is. If I take my derivative of 4x to the 5th, I get 20x to the 4th. If that was anything other than that, I would need to take care of it in my antiderivative. But it's not. It's perfect. So I just have the arc sine then of my u over a, but a is 1, so just my u, 4x to the 5th, and it is indefinite, so I have to do a plus c.